Okay, so let's continue our discussion with relative stability of carbocations. In the last lecture, we have already discussed about what are the factors that contributing in stabilization of carbocation, and as we said, in this class and onwards, we are going to discuss different type of examples, and with those examples, we are going to look upon different concepts associated with stability of carbocation. First, one by one, I will giving you questions and take your time, solve that, and after that, you pause the video, and after that, after your answer match with mine, okay, that will be more beneficial. Pause that video and think yourself, think logically, and after that, come back here. Each and every example first, try to solve yourself. So I am giving you example. First example. First question. There will be 3 carbocations given, and you have to say just stability. CH3 plus, CD3 plus, CT3 plus. This is first question. 1A you can write. Second question. Second question. CH3 plus CD3 and CT3 plus these 2 questions where I have leveled or I have exchanged the hydrogen with its heavier isotope deuterium. So pause the video and think yourself. After that, I'm explaining. After that, you can watch. Okay, let's go to the answer. First, CH3, CD3 and CT3. Here the atom is carbon deuterium or carbon hydrogen or carbon tritium, right? The carbon is positively charged. Then these 3 group cannot show plus R, cannot show plus M. Only the possibility is plus I. And plus I effect from hydrogen to deuterium to tritium, plus I effect increases. So tritium will push more, okay. So that will stabilize the carbocation more. So CT3 will be maximum. So this along this direction the stability will be more. Here the concept is little different. Here the carbon is alpha carbon, and these all 3 hydrogens are alpha hydrogen. These all are alpha deuterium. These all are alpha tritium. So these here, if you compare the plus I effect, then obviously CH3 and CD3 has higher plus I effect than CH3, and CT3 has higher plus I effect than CD3 and CH3 onwards. But here, as 3 alpha hydrogens are there, there is a possibility of hyperconjugation. So here 9 alpha hydrogen is showing hyperconjugation. Here 9 alpha deuterium, here 9 alpha tritium, and hyperconjugation is hydrogen greater than deuterium greater than tritium. So hydrogen shows more hyperconjugation than deuterium and tritium. So in this system, hyperconjugation will be more. If you take consideration only plus I effect, then your order should be 1 to 2 to 3 increasing, okay. But if you consider the hyperconjugation, then in first case, as all 9 are hydrogen, and hydrogen has more hyperconjugation than other 2, then first will be most stable, then second, then third, okay. So there is a competition. If plus I effect you consider, then along this direction stability increases. If you consider plus hyperconjugation, then along this direction hyperconjugation increases. And I have told you in last class that if the competition differ among different groups with their steric and electronic effects appear, then consider hyperconjugation is more prominent than inductive effect. So as hyperconjugation is more prominent, then C to B to A, the stability increases, okay. So most stable will be first one. This is A, if this is B, this is C, then the stability order will be A greater than B greater than C, okay. And for first case it will be this only, okay. So this will be stability order. So in this way, with different examples, we are going to discuss these things. So next question, question 2. Suppose I am giving you examples. Plus, just write with me, plus A, B, C, D. First, think according to you, according to your logic, then watch this, watch my explanation. Okay. So what should be the case? What are the effects? First write them. Don't try to solve manually or non-verbally. Okay. So first write them actually. What are the effects? Here the effects are one resonance, okay, plus R effect of this pi bond, right? One resonance. Here plus R effect. Similarly here plus R effect. Here similarly plus R effect. Okay, this group plus R effect. Fine. Here plus R effect, when you will draw the resonating structure, then carbocation will form here, and this is again stabilized by plus M. So here plus R and plus M is there. Okay. And here in this carbocation, in this particular carbocation, how many hyperconjugative structures possible? According to this carbon, this sp3 carbons are only contribute to hyperconjugation. This will not, if there is a hydrogen, that will not contribute in hyperconjugation. sp2 or sp carbon doesn't contribute in hyperconjugation, only sp3. So there will be 2, and if this undergoes resonance, then there will be positive charge, and for this 2 also, this will be contributing as a hyperconjugative structure. So 2 plus 2, 4 hyperconjugative structure. Okay. Second one, here is 2, and if it undergo resonance, then there will be 2 plus 3. So 3 plus 2 plus 2 equal to 7 hyperconjugative structure. Okay. Similarly for here, this will be 2, and if it undergo resonance, then it will undergo only 1 hyperconjugative structure. 1 plus 2, right? 1 plus 2 equal to 3 hyperconjugative structure. True from here, and when carbon is getting positive here, then for this particular hydrogen on this center will be contributing. So total 3 hyperconjugative structure. And here plus R and plus M, then comparison is easy. We know the plus M or plus R very greater than hyperconjugation, then inductive effect. So here resonance and mesomeric effect both is there, so this will be more stable. So D, all of this has plus R effect, all of these are plus R effect, then differentiation will be through hyperconjugation. 7 will be most hyperconjugating, so B, then A, then C. So D, B, A, C, this will be order. Okay, very simple. Next, let's go to next example. Each and every example is a different lesson. Okay, let's try. Some of these examples actually are previous year questions of different competitive exams where chemistry is a subject. Okay. Some of these questions you can get while solving previous year questions for exams you are preparing in. Okay, so these are 3. So what should be the stability order? This is similar to previous case, so I am not going to discuss it in more details. So I am writing the stability order A, B, C. You will examine yourself and match it with your answer. C greater than B greater than A. Okay. So hyperconjugative structure will be 4, here 4, 7 and 8. Here 2 times hyperconjugation you have to look upon. So first this conjugative structure, so 2, then it will undergo resonance, then here the positive charge will come. So then you have to consider again hyperconjugation, then again you have to do resonance, then again you have to consider hyperconjugation, and one carbon you have to consider at once. Okay, so next question number 4. Different type of examples I am showing. This one, 3 carbon, 7 carbon and carbon on benzene ring. Okay, if this is the question, A, B, C. A is aromatic, B is also aromatic, C is not aromatic, but the carbon is on sp2 center. Carbon on sp3 center versus carbon on sp2 center versus carbon on sp center. If we say the stability order, then this will be stability order, and these things do not form at all. Okay, so this is most stable. Why? We know the more the s character, more the electronegativity. So here in sp3 25% s character, sp2 2 means 1 by 3, so 33% s character, and here it is 50% s character. So more s character is there, so that means this carbon is most electronegative. So most electronegative, more electronegative system cannot hold positive charge. Okay, do not like to hold positive charge. So this is the most likely species to hold positive charge. So sp3 carbon is seen to be positive mostly. Okay, if there is no other extra stability. So C is least stable. Among A and B both are aromatic. Then how to compare that? A is aromatic, and here the resonance or conjugation is being done with 2 pi electron. Here the resonance or conjugation is being done with 6 pi electron. So 6 pi electron. So first A, that is aromaticity plus 2 pi electron resonance. Here aromaticity plus 6 pi electron resonance. So more resonance in B. So B is most stable. B greater than A greater than C. This will be the order. Okay, hope you have understood it. Next question. 5th question. The question is, BH plus NH plus by dimethyl plus then plus similarly actually. So these are for structure A, B, C, D. What will be the stability order? I am writing the answer. So try yourself. A, C, D, B. A, C, D, B. Why it should be? Why it should be the case? Sorry. B, D, C, A. B, D, C, A is the order. Let's understand. Here in B, if nitrogen lone pair undergo resonance like this way, the resonating structure, you can see the ring is like benzene ring or pyridine ring. So this system is become aromatic. So B is when it undergo resonance, so this is actually aromatic system. So B is aromatic, so this is highest stable. Similarly A, structure A, it is anti-aromatic, so it is least stable. 4 pi electron is there. And if we compare C and D, okay, next B is most stable, A is least stable, and D and C, D is most stable because here the 2 hydrogen can undergo hyperconjugation. Okay, 2 hydrogen can show hyperconjugation, but when it is methyl, so the carbon-carbon bond do not show hyperconjugation, carbon-hydrogen bond shows. So here no hyperconjugation. This structure will have hyperconjugation. This will not have any hyperconjugation. So D will be more stable than C. This is how the order is explained. Okay. Next example. 5, 6.